In this video, I'm going to solve this related rate problem. So I'm given that liquid is being sucked out of a cone-shaped paper cup through a straw, and I'm given the rate. I'm given the height of the cup. I'm given the radius of the cup, and I'd like to know how fast the level of liquid is decreasing at a particular time when the depth is 5 centimeters. So the first thing I like to do is I like to figure out what I'm given. And for this problem, it makes a lot of sense to start by drawing a picture. So I've drawn the cup, and I am given that this cup has a height of 10 centimeters, so I've labeled that, and it has a radius of 3 centimeters. And there is liquid in this cup, so I'm going to draw that like this. And I'm going to label the height of the liquid. I'm going to label that H. I'm going to label its radius R. So let's list what we're given. We're told that liquid is being sucked out of the cup at a rate of 3 cubic centimeters per second. So that means that the volume is changing dV by dt. And now think about this for a second. We know that this is a decreasing rate because the volume is decreasing. So that means that dV by dt is negative 3 cubic centimeters per second. So now I'm going to think about what it is that I want. I'm asked how fast the level of liquid is decreasing when the depth is 5 centimeters. So the level of liquid, well, that's the level, right? That's given by the height. So I want the rate at which that is decreasing. So I want dH by dt. I'm expecting that to come out negative because it's a decreasing rate. And I want dH by dt when the depth of the liquid is 5 centimeters. So that's, again, another way of saying that the height is 5 centimeters. Now, the next thing I should do, I should relate my variables. Now, these variables can be related by the volume formula. And the volume of a cone is 1/3 pi r squared h. Now, I've got 3 variables around here, and I think I should think about this before I differentiate, because there may be some things I need to do before I differentiate. If I were to differentiate and that produces a rate that I don't have, then I'm going to be in trouble. So I should try to get one variable in terms of another in that case. So let's think about this for a minute. So if I differentiate, I'm going to get a dV by dt. I have dV by dt. If I differentiate, I'm also going to get a dH by dt, and that's what I want, so that's fine. But this R is going to give me trouble because if I differentiate, I'm definitely going to get a dr by dt, and I don't have dr by dt. So I think I'd like to rewrite R in terms of H. If I could do that, then when I differentiate, I just get a dV by dt and a dH by dt, and I'm good to go. So let's think about how we can get R in terms of H. Let's look a little more closely at our picture. So if I draw a little further up here, I've got similar triangles. So if I compare this large triangle and this smaller triangle, those two triangles are similar. So up in the corner here, I drew a picture of the type of situation we have, which is common in related rates problems. So you have similar triangles, similar right-angled triangles, where one triangle is sitting inside the other. They're similar because corresponding angles are equal, right? They each have a 90-degree angle. they share this angle, and then of course the third one would have to be equal. So what happens when you have similar triangles is that corresponding sides are proportional. So you can say, for instance, that B1 over B2 is equal to S1 over S2. So that is the length of the big side. That side over this one is equal to the ratio of the corresponding sides in the smaller triangle. So back to our picture. So we have, this is 10, this is 3, this is R, this is H. Those are corresponding sides. So that tells us that R over H, so you take the corresponding side to R, and that's 3. So R over H is 3 over 10. And remember, I want to solve for R in terms of H. The reason is because I want to get an H in here because I have dH by dt. Solving for H in terms of R doesn't help you because you don't have dr by dt. So if R over H is 3 over 10, that tells me that R is 3/10 times H. So using that, I'm going to substitute that into the volume formula. And so what I have is V is 1/3 pi times 3/10 H squared times H. And that's equal to 3 pi over 100 H cubed. Next, I'm going to differentiate. And when I do that, I get dV by dt is equal to 9 pi over 100 H squared dH by dt. And I now have everything I need. So let's just substitute and solve. So when I substitute in what I've been given, this is what I get. And I can simplify that now to solve for dH by dt. And I get dH by dt is minus 4 over 3 pi. And that was in centimeters per second. So there's a final sentence, and you can use either one. In the first case, if you're using decreasing, you don't throw in the negative because it's decreasing. We know that it's a negative rate. Or if you don't use the word decreasing, you can say it's changing at a rate of minus 4 over 3 pi centimeters per second.